So, shall we start? Okay, thank you. Good afternoon, everyone. I'm very happy to have you guys here. My name is Yumeng Bao from ZTO Corporation China. I'm a co-contributor from Water Project. And our PTL is Alexander from Slovakia, Russia. And he didn't come, so I am the PTL proxy to give today's Water Project update. In this session, I will give you an introduction about water overview, architecture, and most importantly, what we have accomplished until Pike release and what's our plan for the Queen's release. So, what is water? Water provides the resource optimization service for OpenStack. We all know that OpenStack has done a good job to place virtual machine initially. We use Nova scheduler to handle the initial placement, but what happens over time is that the cloud tends to become imbalanced. So how to rebalance the cloud resources and give rebalancing solutions, that's the first goal of Water. And Water tries to provide different optimization strategies to do the balance according to CPU memory, utilization, or storage capacity. And I'm sure many folks from you may familiar with DRS or DPM, and so we are trying to bring similar technologies into an OpenStack. And secondly, Water also provides a flexible framework for you to customize your own optimization strategy. So if you want to have some customized things, that's perfect fine for you. And one of the things we are very excited with Water is that we have many contributors from all over the globe. And Water project was started by Pike based at France. They did a lot of great work, and also many folks from like ZTE from China and NEC from Japan, Slovakia from Russia, and Intel, IBM, etc. And here is a diagram shows the main components and technical architecture of Water, and also the relations between Water and other OpenStack components. The parts in gray are Water itself. It has three main components: Water Decision Engine, Water API, and Water Applier. When Water API receives a request of resource optimization with a specific goal, Water Decision Engine will find a strategy, or we say an algorithm, to achieve that goal. And according to the chosen strategy, Decision Engine will generate a solution that contains a series of executable actions. The engine will only generate the actions, they don't execute them. And then the Water Applier is the component designed to perform that actions. And of course, Water has its own database. And here at the bottom, you can see other components related with Water. Water uses Noki, Ceilometer, Monasca to collect data on the utilization of physical and virtual resources. And also, Water uses Nova Ground Cinder to collect compute and storage management information. And also, Water Applier will finally invoke Nova or Cinder to execute the optimization actions like live migration or volume migration. And as we just mentioned, when a specific goal is received, Water will find a strategy to achieve that goal and generate a series of actions. Now we have in total 8 strategies in Water. We mainly handle compute and storage resource optimization problems by VM, like live migration and volume migration. Here we can see them in this table. Okay, The first two strategies are outlet temperature and uniform airflow-based migration. And these two strategies will generate actions to move workload when a server's outlet temperature or airflow is greater than a specified threshold. And for the third one, workload stabilization, this strategy will monitor if there is a higher load on some hosts compared to other hosts in a cluster. And once it finds some that higher than others, it will rebalance the work across hosts to minimize the standard deviation of the loads in a cluster. And the number 4, 5, 6 strategies are about VM workload. For the workload balance strategy, it makes a decision to migrate workloads to make total VM workloads of each hypervisor balanced when the total VM workload of hypervisor reaches a relatively high threshold. And for the basic consolidation and the VM consolidation, they both do the consolidation thing. But, sorry. But there is a difference between these two strategies. The basic one is mainly to minimize hosts which have too much or too little load, and the VM consolidation is to consolidate CPU, RAM to some hosts as few as possible. So, which will ultimately lead to free some of the hosts that can be powered down to save energy. And these are the 6. And then here we have another saving energy. This is from, And this strategy is usually used with the VM workload consolidation we just mentioned in the last slide. Because this strategy is usually used for when a data center with large amount of VM and physical hosts. When the workload is not heavy, we use consolidation strategy to consolidate workload to some hosts as few as possible. Then the rest can be free. Then we can use this strategy, save energy strategy to power off or power down the free idle without VMs, idle hosts without VMs, to reduce the power consumption for a data center. And the last one, the 8th one, number 8 is noisy neighbor strategy. This is a kind of RAM level of optimization. It is provided by Intel. And this is about this strategy. About this strategy, it's about L3 cache. This is critical and will limit the system level resources shared by all apps or VMs on one node. There is a situation where this strategy applies. If one VM occupies most of the L3 cache, the other VMs on the node will not have enough L3 cache. So that will cause a relatively poor performance. So this strategy is used to detect the VMs which requires greedy cache, and then we migrate these VMs to other nodes. And that's all the strategies we have now. And for the Pike release accomplishment, and for the first one is about Watcher has now integrated date mode with Cinder. This is quite a big improvement in Pike that we have achieved, and because before we only support compute resource optimization based on CPU memory utilization. We cannot do things like storage optimization. So in the Pike, we have to do lots of preparations for the storage related things, but not, we still don't have any strategies related to storage in the last release, but we will have some in the Queen's release. And we are also trying to make Watcher more user-friendly. So we add some text to VM metadata to let the external system know that VM is in optimization process. And we also, because Ceilometer has changed a lot, so we also made some improvements correspondingly. And for the notification in Watcher, this is previously we have one way to get the resource management information from Nova Cinder. We just invoke their API, and now we add a use notification way. This is another way, or one more way, or another option to get the resource management info from the compute or storage components. This is an event-driven fashion way. And then the next one is a new strategy. This is a dynamic power management strategy. This is just the saving energy strategy I just mentioned. And then the workload characterization. It's just we also made some bugs or other improvements in stability. And then come for the Queen's plans. We will add a date mode to support ironic related resource optimization, or also maybe containers are in our, we're considering adding something about containers. And also one big thing is that we are going to add some storage optimization strategies, zone migration and cluster maintenance strategy. And thirdly, we will also focus on Watcher stability improvement. Here are some details. I will not explain every details here. And then also we will also do some refinement. If you are interested, here is the link about our Queen's blueprints or something. Oh, sorry. And to be honest, the Watcher is a lab project from the beginning. After several releases, practice, we now have ZT and NEC. These two companies are really use the OpenStack Watcher, partly or mostly in their commercial products, cloud products. They both from telecom industries, and tomorrow there will be a user feedback form for Watcher. If you are interested, don't miss it. They will share their experience in using Watcher in telecom industry. And here is the wiki link of Watcher, and we always work on more contributors. If you are interested, don't miss. Come and join us. So that's all for today's Watcher project update. Thank you. And if you have any questions, you can just talk to me or any way you want, please.
Have someone tested Watcher service on infrastructure that has over 100,000 instances?
To be honest, not that large, 100, not that. Thank you. So do you have plans for using Watcher or any ideas? So I was just curious why you asked that question.
There was a time that we are interested to work with Watcher, but in the next few months, I don't know if my company wants to join to the Watcher or install it on the production. I don't know yet, but maybe in the future we'll work on it.
Okay. So what's your companies are in which industrial?
Okay.
I cannot see that. Okay. Maybe you can if you are interested, you can go to our wiki page, or we have RC meeting channel. You can join us. Okay. Any questions? Thank you.